All right, ready to dive deep. Today we're exploring something pretty mind-blowing, the connection between black holes and, well, those everyday water swirls.
Yeah, it's fascinating how something so ordinary can spark such profound questions about the universe.
Totally. Our source material for this deep dive is a conversation between a person and ChatGPT, and they really go deep into this connection.
The idea of projection is key here. How can a simple visual similarity between a water swirl and a black hole suggest something deeper? We'll explore that.
Exactly. And our mission today is to unearth those insights and see what they reveal, maybe even about ourselves.
Intriguing, isn't it?
It really is. Let's start with that obvious visual similarity. I mean, think about it. A swirling vortex in a stream, it's got that dark center where everything seems to vanish, just like an artist's depiction of a black hole, right?
Right, and there's that swirling ring of material around the center. Of course, in water, it's the flow that's pulling things in. But with a black hole, its gravity so powerful that not even light can escape.
Yet, the visual similarity is striking, almost like they're both creating this impression of depth, pulling everything inward. Makes me think about entropy, something you mentioned earlier. Doesn't it apply here, too?
Absolutely. Entropy is this tendency towards disorder, a fundamental principle. You see it everywhere. To keep your life organized, you're constantly battling entropy.
True.
And it's happening on a cosmic scale, too. Both the water swirl and the black hole demonstrate entropy beautifully. Matter and energy are drawn towards a central point, increasing disorder.
Makes sense. But there's this detail in the source material that I found particularly interesting. The person points out that the shape inside the swirl, where the light gets all distorted, it's often a perfect circle, almost too perfect, like it can't be just coincidence. What do you think?
It's a sharp observation, and it gets to the core of this idea of projection. That circle isn't just a visual quirk, it reflects the forces at work. In water, the circular motion creates the shape, but in a black hole, it's gravity warping spacetime itself into that circle around the singularity.
So two totally different phenomena, similar visual effects, all because of the forces involved.
Precisely. And that brings us to the mind-bending part of this, the idea that both the swirl and the black hole might be projections of something even more fundamental, wave functions.
Wave functions. Sounds like we're diving headfirst into quantum mechanics.
But bear with me. This is where it gets truly fascinating.
Honestly, wave function always makes my brain melt a little. Can you break it down? What is it and how does it connect to these swirling systems?
Imagine a wave function as a map, not of a fixed location, but of all the possibilities of where a particle can be. It describes a particle state or a system state in terms of its potential.
Okay, so it's about possibilities, not a fixed point. I'm following.
Now, in a black hole, that map gets warped, just like space and time, and that warping creates the visual effect of the circular distortion we see.
So the circular shape, it's not a physical thing, but more a visual representation of how the wave function is being distorted by that extreme gravity.
Exactly. And that's the parallel with the water swirl. Think of the water itself as the wave function, that swirling motion, a visual expression of how the water's energy and momentum are shaped by the forces acting on it.
Okay, starting to click a bit more. But how does projection apply to something as vast as a black hole? We're talking about objects that warp the fabric of space-time.
That's what makes this connection so profound. It suggests that what we see, even on a cosmic scale, might just be a projection of something much deeper. The black hole, with its singularity and event horizon, it might be a manifestation of how these wave functions are warped and distorted by extreme gravity.
So we're seeing the effect, but not the cause.
You could say that. Think about a shadow. It's not the object itself, right? It's a projection created by light interacting with the object. Similarly, those swirling patterns, both in water and a black hole, might be projections of these wave functions shaped by the forces at play.
This is making me think about how we perceive reality in general. Could everything we see, everything we experience, just be a projection of something more fundamental?
It's a profound question, pondered for centuries. If this connection between black holes and water swirls teaches us anything, it's that there might be more to reality than meets the eye. What we perceive as solid and static might actually be fluid and dynamic, shaped by forces and energies we're only beginning to grasp.
Wow. Definitely makes you rethink things. So we've got these swirling systems creating those circular projections and potentially pointing towards a deeper reality of wave functions. But how does this all tie back to that initial observation about the impression of depth?
That's a great question. It leads us to one of the most intriguing parts of this discussion, the interplay between coherence and decoherence.
Okay, now you've got me intrigued. Let's unpack that. What do you mean by coherence and decoherence, and how do they relate to these projections?
Okay, so think of coherence as like a state of order and stability. A smooth flowing water swirl, that's a great example of a coherent system. Everything's moving together, harmoniously.
Yeah.
Decoherence, on the other hand, is like the opposite. It's the introduction of disorder and chaos. Imagine that same water swirl becoming turbulent and disrupted. That's decoherence in action.
So in a coherent system, the wave function is stable and well-defined, and in a decoherent system, it gets more spread out, more chaotic.
You got it. And what's fascinating is that both the water swirl and the black hole, they both exhibit this interplay between coherence and decoherence. That smooth circular flow of the water that represents a kind of coherence, but as things get pulled inward, they start to lose their order and stability. That's the decoherence at play.
And how does that apply to a black hole? I mean, they seem pretty chaotic by nature.
That's where it gets really interesting. Think about the accretion disk, that swirling disk of matter spiraling into the black hole. It's chaotic, turbulent, matter's constantly colliding, getting torn apart. That's a prime example of decoherence.
So even though the black hole itself might be a projection of a highly coherent wave function, the environment around it is a hotbed of decoherence.
Precisely. And that brings us back to that idea of depth. The impression of depth we get from both the water swirl and the black hole, it might be a visual representation of this transition from coherence to decoherence. As things get drawn inwards, they lose their order, they lose their stability, they become more chaotic, more unpredictable.
That's a really fascinating way to think about it. It's like the depth we perceive, it isn't just physical, it's also a measure of how much decoherence is happening. The further in you go, the more chaotic things become.
Exactly. And that connection between depth and decoherence might have profound implications for how we understand the universe, and maybe even ourselves.
Okay, now you've really got my attention. What kind of implications?
Well, for starters, it challenges our traditional notions of space and time. If depth is more than just a physical dimension, if it's also a measure of decoherence, then it suggests that space and time might be more fluid, more interconnected than we tend to think.
So instead of thinking of space and time as fixed and absolute, we should think of them as more dynamic, more relational, influenced by this interplay of coherence and decoherence.
Precisely. And that shift in perspective could have a ripple effect across various fields of study, from physics, cosmology, to even biology and consciousness.
You mentioned biology and consciousness. Could you elaborate on that a little? How does this concept of decoherence apply to living organisms, to the mind?
Think about it this way. Our bodies are highly organized systems. We maintain a delicate balance of temperature, chemical reactions, electrical impulses. That's a lot of coherence. But we're also constantly interacting with our environment, exchanging energy and matter, undergoing processes of growth and decay. That's where decoherence comes in.
So life itself is this constant dance between coherence and decoherence.
Exactly. And the same could be said for consciousness. Our thoughts, feelings, perceptions are constantly changing, evolving. There's a certain level of coherence in our conscious experience, but there's also a lot of decoherence as we interact with the world around us.
This is making me think about those practices that emphasize mindfulness and meditation. They're all about cultivating a sense of stillness and focus, which seems like it would promote coherence in the mind.
That's a great observation. And there's growing evidence to suggest that these practices can have a measurable impact on our mental and physical well-being, perhaps by influencing that balance of coherence and decoherence in our systems.
This whole discussion is really making me question my assumptions about the world and my place in it. It's like we're peeling back the layers of reality and discovering a much more complex and interconnected universe than we ever imagined.
That's the beauty of exploring these kinds of connections. They challenge us to think differently, to see the world with fresh eyes, and to appreciate the profound mysteries that still lie hidden beneath the surface.
Absolutely. But I have to admit, my brain is starting to feel a little overloaded. I think we need a moment to process all of this before we dive any deeper.
I agree. Let's take a pause and let these ideas settle in. When we come back, we can explore some of the potential implications of this understanding of projection, coherence, and decoherence for fields like health and energy.
All right, phew, my brain needed a minute there. We've covered so much: projections, wave functions, coherence, decoherence. It's a lot. But I'm ready to dig into those potential implications you mentioned, especially for health and energy. The source material had some pretty bold claims about that.
It's exciting, isn't it? To think where this might lead us, let's start with health. If we view the body as a complex system, energy and information constantly balancing coherence and decoherence, well, it makes sense that disruptions in that balance could lead to illness.
So are you saying restoring coherence could be the key to healing? That reminds me of those quantum healing ideas. I've always been a bit skeptical.
Healthy skepticism is good, especially with emerging fields. But think about traditional healing practices. They often emphasize balance and harmony, right? What if those ancient intuitions were tapping into these deeper principles of coherence and decoherence, even without the scientific language to describe them?
Interesting thought. So maybe instead of dismissing these practices as woo-woo, we should look at them through this lens of quantum mechanics, see if there's some scientific basis for why they seem to work.
Exactly. Imagine technologies that could measure and manipulate those subtle energy fields in the body. We could detect and correct imbalances before they even manifest as disease, or even speed up healing by promoting coherence.
Sounds a bit like science fiction. But if this understanding of projections and wave functions holds true, maybe it's not so far-fetched.
And it's not just health. The source material also touched on energy. If everything is ultimately energy, shaped by these wave functions, then maybe there are energy sources all around us that we haven't even dreamt of yet.
That's where that idea of zero-point energy comes in, right? The energy of the quantum vacuum.
Right. Some physicists think this sea of quantum fluctuations could hold the key to clean and sustainable energy. But tapping into it has been a major challenge.
So how does understanding projections and wave functions help us tap into this zero-point energy? It still seems very theoretical.
That's the million-dollar question. But here's a thought. If we understand how these projections come from underlying wave functions, perhaps we could manipulate those wave functions to create localized regions of energy density.
So instead of extracting energy from the vacuum directly, we'd be shaping the vacuum itself, creating pockets of usable energy.
That's the idea. Sounds crazy, maybe, but we already manipulate electromagnetic fields to create electricity. What if manipulating wave functions is the next big thing in energy tech?
Mind-blowing concept. But wouldn't tapping into zero-point energy violate the laws of physics? Creating energy out of nothing seems a little too good to be true.
It's a common misunderstanding. Zero-point energy isn't nothing. It's the lowest possible energy state of a quantum system. But it's still energy. And quantum mechanics says energy can fluctuate in and out of existence as long as certain conservation laws are followed.
So it's not about breaking the laws of physics, but about understanding them well enough to use them in new ways.
Precisely. That's what makes this whole topic so exciting. It pushes us to challenge what we think is possible and to explore the universe with wonder and curiosity.
It's been an incredible journey. We've gone from water swirls to black holes to quantum mechanics and the very nature of reality. A lot to absorb, but I definitely feel inspired to learn more.
That's the best takeaway we could hope for. The universe is full of mysteries. And it's through exploration, through these deep dives, that we uncover those hidden connections and expand our understanding of ourselves and our place in the cosmos.
Well said. And to our listeners, thanks for joining us on this journey. Keep questioning, keep exploring, and keep looking for those connections that reveal the wonders of the universe. Until next time.